Okay, so I'm going to go over negative exponents. I don't really have a video on this on the existing videos that I have, so I thought this would be a good thing to just focus on negative exponents because this concept is usually weird for people. So I'm hoping that this will kind of clear things up and give you sort of an understanding of why they exist. So first, we're going to just start with the definition of an exponent, which is basically you have repeated multiplication. So if I just have a whole bunch of 2's multiplied together, we use an exponent to indicate that. And so we have 5 2's here, so this would be 2 to the 5th. And it's just a shorthand, so we don't have to write it out all the time. You know, it saves space. So let's think about what happens if we're not multiplying. What if we had a lot of divisions going on? So what if I was dividing by 2 many, many times? So addition and division are considered sort of opposites or inverses. They undo each other. So if you think about an exponent, if you have a positive exponent for repeated multiplication, then for repeated, sort of the natural analog or kind of opposite would be a negative exponent because it's a negative, it's the opposite of a positive. So I have 1, 2, 3, 4, 5 2's here, but they're all being divided, so I can write this with a negative exponent, 2 to the negative 5th. So if you think about things being positive and negatives, you can think of negative exponents as we're dividing by that exponent multiple times versus multiplying multiple times. And another way to look at this is if I converted all of those divisions to multiplying by the reciprocal, because we know that division can be written as multiplication. So if instead I turned all of these to multiplying by the reciprocal of 2, which is 1/2. I'm just going to write this out. This would be, we basically have a 1/2. 1, 2, 3, 4, 5 times multiplied together. Or you could think about it as all the 1's get multiplied together, which is just 1. And then in the denominator, we have 2 to the 5th.
Okay.
So this leads us to our rule here, which is something with a negative exponent is the same as taking the reciprocal and then having the exponent positive. So basically here, if we rewrite these 2 different ways, like, so I wrote it with repeated division, that gives us 2 to the negative 5th, and then I wrote it where if I multiplied it, it's 1/2 multiplied multiple times, or 1 over 2 to the 5th. So you can see that 2 to the negative 5th is equal to 1 over 2 to the 5th. So again, that's what brings us to this rule of negative exponents, where if you have a negative exponent, you're basically taking the reciprocal, and then the exponent becomes positive.
Gotcha.
And it also works the other way, that if you have a negative exponent in the denominator, that's the same as a positive exponent in the numerator. So you can do these back and forth, and this comes from just the definition of an exponent and then looking at what is the analog to it. You know, if we're multiplying multiple times, what happens if we divide multiple times? Now, the textbook describes this a different way, which is also a very good way to describe it, where they show you a pattern where you have, you know, like 2 to the 3rd, 2 to the 2nd, and you count down by 1 for each exponent, and you see that your numbers get divided each time, and that's how it leads us to the negative exponent. So I would check that out as read through that section. I think it's 5.3.
Mm-hmm.
I'll make a note right here because it does a really good job of explaining, just explaining another way to look at it and to look at a negative exponent. So I'm just going to go through and do some practice of rewriting these exponents just so you can see how they work. So when you have something like 5/3 with a negative exponent, so if I go back here, that negative exponent is saying that you're taking the reciprocal. So what we do with a fraction is we take the reciprocal of the fraction, so that would become 3/5, and then the exponent becomes positive. So simplifying this would just be 3/5. So if you have a fraction with a negative exponent, you're just taking the reciprocal, and then that negative exponent becomes a positive. My second example here, we have 5/2 to the -1. So when we take the reciprocal, we're only taking the reciprocal of what has the negative exponent. So the example on the left, the whole thing was had a negative exponent, so you take the reciprocal of the whole thing. Here, only the 2 has the negative exponent. So you're only taking the reciprocal of the 2 in the denominator. So first, let me rewrite this. This is what we see right now. If we isolate the part with the negative exponent, we have 5 times, and then this 1/2 to the -1, and that 2 to the -1 has the negative exponent. So we're taking the reciprocal. So if the 2 is in the denominator, it's now in the numerator. And so that would become 5 times 2 to the +1, because when we get rid of that negative, it just flip-flops from whether it's on the top or the bottom, basically. And then 2 to the first is just 2, so 5 times 2, and this simplifies to 10. A few more examples here. So we've got -1/3 to the -2. So first thing is we want a positive exponent because that's easier for us to work with, basically. We know how to square things. We know how to cube things. That negative exponent just kind of isn't natural, easy to think about. So we're going to take the reciprocal because we've got a negative exponent on a fraction. It still stays positive. So this would be -3/1 to the positive, so or it still stays negative. So we have a negative inside there. That negative exponent doesn't change that because we're just taking the reciprocal. So we still have a negative inside the parentheses. It's just instead of 1/3, it's now 3, or 3/1. And then your outside exponent is 2. So what we're looking at here now is actually -3 squared. -3 times -3 is a +9. And you can even put this in your calculator. Your calculator can do negative exponents, and you can verify that you will actually get a +9 out of here. On the right, again, we have this -2 exponent. We take reciprocal of basically what's in the parentheses here. So if we have 3/b, it's not a fraction, so it becomes a fraction. So it becomes 1/3b, and then we're squaring it. So when you're squaring, and as you square 1, it's just 1. So this really is 1/3b squared. So it's 3b times 3b. So you're squaring the 3 and you're squaring the b. So 3 squared is 9. And then we also square the b. So we end up with 1/9b squared. So that negative exponent of 2 is like squaring. It's just kind of, you square it and then you're taking the reciprocal basically before you square. Are there any questions so far? And I muted both of you guys, so you'd have to unmute yourself.
No, ma'am. I think it's pretty simple. It's simple seeing you do it.
Yeah.
But when we get into the books and start doing it, it's like we panic. Probably, I know I do.
Yes. I think that's definitely. It's like a panic. It's like, oh no, I don't know what to do. But it's like you do. You really do.
Right. Because I mean, this like here, like this, what you just did here with um, the negatives, the one before you did this last one, the -3 to the square, and
Mm-hmm.
you multiply it. I mean, that part I don't. I mean, I can comprehend that pretty understandably. Should I say that's the proper word? Yeah. But some of them, I don't know. Like I said, it must be me panicking or something. I freak out, and I'm like, okay, I know this isn't hard.
Yeah, I think a lot of it is it starts to look different, and then you're like, oh no, what do I do? And it's just a
Right.
matter of breaking it down, what do you know, and then going from there.
Okay. 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 Well, I understand, kind of, sort of.
We'll see. I've got lots of examples. So,
Okay.
so here I've got 7t to the -3. So in this case, only the t has the negative because it's not in parentheses. So that's really important to pay attention to because the parentheses group things together, and if they're not in parentheses, you assume it's only what it's directly attached to. So that means that when we want to get a positive exponent, we're looking at just taking the reciprocal of t to the -3. So you want to make sure that you separate that out. So we're taking the reciprocal of t, which basically is 1 over t, and then you're now going to have a positive 3 exponent instead because you took that reciprocal. And then generally when we write this, we combine it again into a single fraction. So that would be that 7 would be multiplied by the 1 on top, and then you end up with t cubed in the denominator. So usually I don't show this much work. I just know it's going to be in the denominator, and I usually just write it. Like I know -5u to the -2 is going to be -5u squared because I know that u to the -2 is going to go into the denominator. But you want to kind of get used to showing those steps so that you can see what you're doing and understanding the process. That you're taking the reciprocal of that u to the -2, which makes it 1 over u squared, and then you're recombining them. And that negative in front doesn't have anything to do with the negative exponent, so it just hangs out. People are very prone to losing negatives or multiplying negatives here because they want to do something with them together, but because one is in an exponent, one is outside of the exponent, they don't interact. So you have to be very careful about what's in an exponent, what is out of an exponent, because you can't combine those in any way. Those just don't go together.
Hey, Stephanie.
Yes.
Okay, I do have a question. I kind of got confused on that. So here goes my confusion question. Hello. So when you made that into the u, and then you had that square -2, and you made that into a fraction,
Mm-hmm.
the negative, and make sure I'm understanding right, made it a 1 over u2. Is that
Mm-hmm.
right? Okay. Okay. So
Yes.
so the negative ended up being the 1, and then you took it away from the 2, which made it a 1 over u2, right?
Yeah, I mean, basically this negative exponent just indicates to take the reciprocal
Uh-huh.
and make the exponent positive. That's what it's telling us.
Okay. Okay.
So it's not like it's weird because it's not like I don't want to say that it's like, you're like multiplying by an exponent disappears or kind of thing like that. It's just this rule of negative exponents.
Okay.
That if you have like something to a negative, it doesn't even matter what I put in there, but we always rewrite it as reciprocal with the positive exponent. And it's more definition versus we're doing something to the negative. It's just we're rewriting it.
Okay. Okay, I understand now. Okay.
Okay.
Thank you.
Yep. So here's some with some negatives in the denominator. So we have 2 over g to the negative 4. So only this g has a negative exponent. So that's the only thing that we're taking the reciprocal of. And so we could rewrite this as 2 times 1 over g to the negative 4. So I'm separating those out so you can see what we're taking the reciprocal of. We're not touching the 2. That doesn't have a negative exponent. It's not combined with any parentheses or anything like that. So only the g is going to be flipped to get the positive exponent. So this will be 2g to the 4th. And it's similar here on the right. We have 3x over h to the negative 1. So that 3x doesn't have a negative exponent. So those are not moving, so to speak. But if we have h in the denominator, that's the same as 1 over h. And then it has a negative 1 exponent. So we want to get rid of that exponent. We want to rewrite it. So that becomes 3xh because we're taking the reciprocal. So now it's on top. And then the negative 1 exponent is the same as just a 1 exponent, which we usually don't write. So this would just be 3xh. So we're saying we're rewriting these because we're just literally using a definition to write it in a different form. They're equivalent. We're not really, it's just a different way of writing it. It's not like we're doing math to the exponent or anything. It's different.
Gotcha.
So often people are like, well, why do we even have these? Why do we need to know these? So I want to show an example of how you can simplify if you didn't use negative exponents at all, and then how you can simplify using negative exponents so that you can kind of see, well, what might be easier for you, because some might make more sense to you. So it's just a different technique, basically. And in some cases, you can't avoid negative exponents. And that's where when you simplify and you always end up with a variable in the denominator, that would always end up with like a negative exponent. But here we have 2x squared times 3x to the 5th over x cubed. So if I was not to use any negative exponents and I wanted to simplify this, the first thing that I would do is to multiply on the top. So you'd multiply your numbers 2 times 3, which is 6. And then you add the exponents, 2 plus 5, which is 7. So our rule when we're multiplying things with exponents is that you add them together. Your next step when you have something with a fraction is you subtract the exponents. So we would be subtracting 7 minus 3, and we would result in 6x to the 4th. 7 minus 3 is 4. And so we don't use any negative exponents here. We're just using our two rules, a rule for multiplying with exponents and then the rule when you're dividing things with exponents. Now on the right, we can do the same problem with negative exponents. And if we did this with negative exponents, what we would want to do is rewrite the one in the denominator as a negative so that they're all on the same side, or basically all on the top. So this would be 2x squared times 3x to the 5th, and then we would take that x to the 5th, which is in the denominator, and make it in the numerator by giving it a negative exponent. So I would just rewrite it. So now they're all on the same level, and so now we're multiplying, which means you multiply the numbers, 2 times 3, which is 6, and then you add all the exponents, and so you can add them all at once. 2 plus 5 is 7. 7 minus 3 is 4. So you get the same answer, but by using negative exponents, you didn't have to write any fractions. So you can do it this way, get the same answer. It's just a different method. The rules basically operate the same, but you can see how the steps look different based off of whether you use negative exponents or not. So out of these, which one do you prefer for this particular problem? After you've seen both of them worked out, what kind of makes more sense to you?
I think with the negative exponent makes more sense.
Mm-hmm. Yeah, I also think it's a little easier because then all you're doing is adding them. What about you, George? What do you think?
I think the same thing because it's kind of more explanatory than trying to do it out of the fraction side.
Mm-hmm. Yeah, so knowing this, you can always turn something that has fractions into something without fractions by changing the exponents and then working with it. Now, sometimes you can't avoid it because if it's a negative exponent on a number, this is not going to help you. But if it's negatives, if there's like variables in the denominator, this is a way you can use negative exponents to make it just look easier. So I'm going to start going through simplifying with different variables, different combinations of exponents, just practicing all of these rules of exponents that we use so you can see the whole process and, just kind of talking about the steps that I recommend doing each of these, what I think is easier. So on the left here, we have j squared j to the negative 8. So our rule here is when they're multiplied, you add the exponents. So we just do 2 plus negative 8 or 2 minus 8 here, which would be negative 6, j to the negative 6. Now we don't keep our answers with negative exponents. We always want to rewrite them with a positive exponent. So you're going to then take the reciprocal. So that becomes 1 over j to the 6th power. So any homework that you turn in, anything, you'd never want to leave it with a negative exponent. We use the negative exponents because they're useful in the process of simplifying things, but we generally never leave our final answer in that form. Now on the right here, we have n to the negative 4 f squared, and then the whole thing is to the negative 3 power. So when I have something like this, and I don't have a fraction and I have a negative exponent here, I will first multiply my exponents out, and then I will do the conversion from any negatives to positives. So because sometimes your negatives will cancel out with the multiplication. So I just find it easier to distribute the exponents first. So you're multiplying. So our rules of exponents here is when you have that outside exponent, it applies to everything on the inside. So both the n to the negative 4 and the f squared get that negative 3. And then we simplify this by multiplying exponents. So negative 4 times negative 3 is a positive 12. And then 2 times negative 3 is a negative 6. So we have n to the positive 12 and then f to the negative 6. And that f to the negative 6, that's what we want to take the reciprocal of because it has a negative exponent. So I'm going to leave my n to the 12 alone, but I'm going to take the reciprocal of the f, and that's going to give me a positive exponent, but it's in the denominator. And then we recombine these into a single fraction. So the n on the 12 is on top, and then the f to the 6th is in the bottom. So the last step is to recombine after you do any flipping. Now here are some, and this is where you may find it easier to rewrite all these fractions by taking the reciprocal so that you have them all in one line. So first here on the left, we have q to the 5th over q to the negative 7. So it may be easier if you take that q to the negative 7, which is basically as a fraction on its own, and to take the reciprocal of that, which then gives a positive exponent. Because then you're basically just adding your exponents together, 5 plus 7, which is 12, and you end up with q to the 12. It's easier than using the subtraction rule, because if you're subtracting, you usually do 5 minus a negative 7, and that's where errors occur because you're subtracting negative, and that tends to cause issues. You know, people will forget to subtract and they'll add them instead, or, you know, there's usually negative sign issues there. So rewriting it so that they're all on the top can make it easier for you. And we can do the same thing in the second one here. We have k to the negative 4, h to the negative 1, over k to the 8, h. So I can put my k's together. And so anything that's in the denominator, you can write that as a separate fraction. And so I can actually separate these out like this, because when you multiply them together, you'll get back to the original. And because order of multiplication doesn't matter, I just rearranged it so that I put the k's together and the h's together. So everything that's a fraction, I can rewrite it with a negative exponent so that I can just add these things. So we have k to the negative 4, then k to the negative 8. And we have h to the negative 1, and then if it's 1 over h, that is just going to be h, and then you can give it a positive 1 if you want to add those together. So now they're all on the same side. They're all basically in the numerator, so you can add the exponents because they're multiplied together. So with the k's, you have a negative 12 minus 8, or negative 4 minus 8, which gives you negative 12. And then on the h's, you have negative 1 over 1, and oops, that should be a negative 1. It's negative 1 minus 1, because that h has a positive exponent 1 in the denominator. We flip it, it becomes a negative. Helps to write those exponents there so you can make sure you do that correctly. So with the h's, we have a negative 1 minus 1, so that's a negative 2. Now, everything here is a negative exponent, so that means when we write it with a positive exponent, everything is going to be in the denominator of a fraction. So we're going to end up with, I'll just put it over the right here, 1 over k to the 12 h squared, because both of those are going to end up in the denominator when you flip them. We don't have any numbers, so if nothing's going to be on top, we just write a 1. Are there any questions?
No, that was a tough one right there, but
yeah, it's got a lot of moving steps, and you have to keep track of your exponents, which even I messed up. So it helps to write down the exponents, and if it's not there, so you can make sure you flip it correctly. So whenever I have exponents on the inside and exponents on the outside, I multiply first. So
Okay.
I'm going to multiply and I'm going to distribute. And I have not left myself a lot of room here as I'm looking at these. And I'm like, oh, I should have left myself more room. So I'm going to just do the multiplication step. So on the top,
Okay.
you would have 3 times 4. So you're going to get d to the 12. And then with the t, you have a negative 2 times 4. So that's a negative 8. Now in the denominator, that negative 2 goes on the number, so that's not multiplication. So I'm going to just write that with an exponent, because the 3 doesn't have an exponent, so now it's gaining an exponent from there. And then we're multiplying on the d, the negative 4 times the negative 2, which is a positive 8. I almost wrote 16, definitely not right. And then on the t, we have 6 times negative 2, so that's negative 12. Then from here, we can do what we did before, where everything in the denominator, we can put it in the numerator by flipping the sign on the exponent. So like the 3 in the denominator, to put it in the numerator now gets a positive exponent. I have a d12 and then I can take that d to the 8 and flip it, but now it gets a negative exponent because when you change the sign when you do this. So you can try to, so these are becoming this. And then I can do the same thing with the t. So on the top I have t to the negative 8, and then I have a t to the negative 12, so that becomes a positive 12 when we flip it. So these give me this. So I'm just rewriting everything, so now it's all in the same line. And then we're going to basically simplify. So I've got 3 squared, which is 9. And then I add my exponents on the d. So that's 12 minus 8, so that's 4. So we get d to the 4th. And then we have a negative 8 plus 12 on the t, which also gives me 4. So then we end up with t to the 4th. So you have to do it. You have to be very meticulous as to first multiply all of your exponents on the outside, then flip everything using that rule where you're basically changing the sign of the exponent and then combining them.
Okay, I have a quick question again.
Yes.
Because see, I'm asking questions after questions.
Oh, this is good. I love it when people ask questions.
Okay, so you had the D12 and the D negative 8. And when you brought it down to the answer where D4, is it because the 12 was a positive?
Because we have 12. We have 12 plus negative 8. Okay. So that's the same as 12 minus 8, which gives you 4.
Okay. But it made it a positive instead of a negative.
Yes, because there you just strictly do the math and you don't have to do any flipping. It's just 12 minus 8 is a positive 4, so that's what we have on the exponent.
Okay, got it. Okay, that explains it. Thank you.
So we're going to do the same thing here on the negative 2. And actually, I'm going to look at this first to see if there's anything that might make it easier on the inside before I do the negative 2. Because sometimes you can make things easier and then take care of the whole exponent kind of thing. So, because there's multiple ways to do these, you can do these in different orders. So that's kind of the hard part for a lot of people, is that the order that you do these steps, really, you can do things in multiple different orders and you'll get the same answer. So it's just a matter of what makes sense to you. So when I see a fraction on the inside, and this is the whole fraction is to the negative 2, as opposed to the left where there were separate exponents, but if I see a single exponent on a fraction, I do different steps. I do it in a different order. So I usually simplify the inside before I take care of the outside exponent in a situation like this. So first off, I've got this 4 over 2, so I can divide that. 4 divided by 2 is 2, so I'm going to just write 2. Now, what I'm going to do is try to simplify and put these all in the same line so we can simplify the insides. So maybe I'll even just color code these. So we have our m to the 10, and then the m to the 12 that's in the denominator, we put it in the numerator by giving it a negative exponent. So we're changing that sign. Then I've got my n's, and I can do the same thing here. I have n to the 4th, and then in the denominator, it's a negative 2, so when it goes in the numerator, it becomes a positive 2. And then we still have that outside exponent of negative 2. So I'm simplifying the inside in this case before I do the outside because they're all within one parenthesis. So I've got 2, and then I add my exponents. 10 minus 12 gives me negative 2, so that's m to the negative 2. And then on the ends, 4 plus 2 is 6. So I have 2 to the m to the negative 2, n to the 6, and then the whole thing is to the negative 2. And Now this is when I'm going to distribute my exponent. So this is where I'm going to take this -2 and apply it to each of these. So that would give me a 2 to the -2, because that, if it's a number, it just gets that exponent. And then on the variables with exponents, you multiply them. So we have a -2 times a -2, which is a 4. And then on the n, 6 times -2 is a -12. So now I have 2 to the -2, m to the 4th, n to the -12. And anything with this exponent, we need to take the reciprocal. So that's going to be 1/2 squared. We have m to the 4th, and then we have 1/n to the +12. And now we're going to combine these into one fraction. The m to the 4th is going to be on top. 2 to the squared is going to be on the bottom, which I can just square. That's 4. And then we have n to the 12th. And so that's how that one simplifies. If I had more room, I would have left a little more spacing here so it's not so smushed. Should have planned ahead there. But all the fractions, those parts went in the bottom. So all the exponents are in the bottom, and then the positive exponents are on the top. Any questions?
I like the way you did that, and I wrote that one down with it.
Okay.
That was a very good example.
Yeah, and it's funny. I don't usually do these this way, but since this is how you guys said you liked putting it in, having it all, because I'll use the subtraction rule, but since when we did that other example, you guys preferred the negative exponent way, I figured, okay, I'll do these the negative exponent way. So
yeah. Now, if you would have started that off, just curiosity, and if I'm wrong, tell me, it's fine. If you would have done it the other round way at the very beginning, where it had the -12 at the bottom, and then you had outside the parentheses the -12, would you wipe those two out? Am I confusing? I don't want to confuse anybody.
I'm trying to
see where it has the n -2. Okay, so you have the problem at the very beginning.
Yeah.
Okay, and right there where the -2 is by the n, and then outside you have the -2. You don't wipe any of that out, right?
No, because if they don't cancel, they would be multiplied together if you were going to do it that way.
Okay. I just wanted to, because
yeah. Now, if instead of the 4, if instead of the 4 it was a -2, those could cancel out because those match on the top and the bottom of the fraction.
Okay.
But if it's outside, that would not.
Okay, explained it. Thank you.
That's a good question. That's a very good question.
Good. Thank you. I was just curious. I knew that you marked them out somewhere, somehow or another. You can mark them out. So.
Yes, they would just have to be on the same fraction.
Okay, that's understandable. Thank you so much.
Any other questions?
No, ma'am.
All right. Well, that's all I have. So hopefully that has cleared up or helped you out. So when you do the homework with these and you end up with those negative exponents, you have a better idea what to do. And even if you have things without negative exponents, the rules are the same. We're still multiplying things together and that. So hopefully this helps you even with things that don't have any negative exponents at all. So.